Dear students, welcome to our science episodes. Today we are going to discuss light energy lenses. Well, let's continue lenses, and we will talk in this episode about images formed by the concave lens. Look at this picture. The object is here. What can you see? The incident rays, or the rays are hitting the lens, and then this lens is a divergent lens, so they will diverge the light rays, and the intersection of these rays will form a virtual, smaller and upright image. Give reason why it is impossible to have a real image using a concave lens. Take a second to think about it. And the answer is, this is because the image is formed as a result of the extension of the reflected light rays. So you will see these are the light rays which will hit the lens, and because this lens is a diverging lens, so it will separate the light rays away. The extension of these reflected light rays will make the image. That's why it's always a virtual image. It's not a real image. Now let's discuss the human eye. This is the anatomy or a cross-section of the human eye. As you can see, the human eye is formed of a cornea and of course the iris and the pupil. The pupil is an opening where the light rays enter. Here is a lens of the eye inside the eye globe, and you can see the lens of the eye. It's a convex lens where it will take the light rays and focus it on the retina, making an image. So the eye globe, let's see together, the eye globe is spherical. It's like a sphere. The lens, the second information is the lens is a convex lens. The retina is a thin layer of tissue that lines the back of the eye. Light enters the eye through the cornea first and the pupil, and it's focused by the lens and refracted on the retina. The image formed on the retina is small and inverted. The retina will convert the light into signals and send them through the optical nerve to the brain for image recognition. So the eye is taking the light rays and it's forming an image. But which organ is understanding this image or recognize this image? The brain. So at the end, the retina will send nerve signals through the optical nerve to the brain to recognize and translate this image. The person with normal vision sees the object clearly at a distance between 25 centimeters to 6 meters. We use lenses to treat the vision defects. Of course, some of us wear eyeglasses, and these eyeglasses contain lenses to treat the vision defect. Vision defects could be short-sightedness, and this is when the person will only see the near objects clear, but the far objects are blurry, are distorted, because the images of these objects do not fall on the retina, they fall in front of it. So if you can see here, this is short-sightedness, where the object or the image will fall or will form in front of the retina. So I can see the cause of short-sightedness may be elongation of the eyeball. The eyeball is elongated, which causes the retina to be far from the eye lens. Or the surface of the eye lens is more convex, which result in a small focal length. and the parallel rays will be collected in front of the retina, not on the retina, resulting in an unclear image. And we are correcting the short-sightedness with a concave lens. So if you have a short-sightedness, you have to wear an eyeglass with a concave lens, which diverges the rays and then will cause the image to fall exactly on the retina. The other type of the vision defect is long-sightedness, where the person can see the far objects clearly, but the close objects are blurry or distorted because the object or the image will not fall on the retina. They will fall behind. The image will form behind the retina, not on the retina. And this could be because the shortness of the eyeball. This could be because of the shortness of the eyeball, which causes the retina to be close from the eye lens. Or the surface of the lens is less convex. This may be due to shortness of the eyeball, which causes the retina to be close from the eye lens. The retina will be so close to the eye lens. Or the surface of the lens is less convex. So this will cause increase in the focal length and the parallel rays will be collected behind the retina. This is corrected by a convex lens. So if you have a long-sightedness, you will wear a medical eyeglass with a convex lens. And it will converge the light rays and will form the image exactly on the retina. These are contact lenses. And they are sometimes used instead of the glasses. They are very thin lenses and they are made of plastic. They can stick to the eye cornea by the eye fluid and correct the vision defect. So let's now talk about what is called cataract. What do you know about cataract? It's a disease. It's when the lens is cloudy. Can you see this picture? If the lens is clear, we cannot see it. But if the lens is cloudy and opaque, we will see it through the pupil of the eye. So it's the cloudness and the opacity of the lens of the eye that leads to a decreased vision. The normal lens is always transparent. Causes of cataract. Sometimes there is hereditary factors, genetics. It's inherited from one of the parents. Sometimes it's due to aging. So old people are liable to have cataract. Other diseases associated. Some diseases are associated with cataract. Drug side effects. Some drugs are causing the lens to be opaque. And what is the treatment for the cataract or the cloudness of the lens? The treatment is surgical by removing the lens and replacing it with a clear artificial one. Now please choose the right answer. An image formed by a concave lens is virtual upright and small, virtual upright and large, virtual upright and equal in size, real inverted and large. What do you think about an image formed by a concave lens? Of course, it's virtual, upright, and small. Is used to correct short-sightedness. It's a convex lens, a concave lens, a plane mirror, a convex mirror. The answer is a concave lens, of course, because it's a diverging lens. In long-sightedness, the image is formed on, behind, in front of, or below the retina. And of course, it is behind the retina. Now let's watch this video about lenses.
If you look at a scene through a single lens, it appears upside down. Why is that? Lenses that are thicker at the middle are called convex lenses. These lenses cause parallel light rays to converge to a single point, called the focal point. When light rays pass through the lens, they do not travel in straight lines, but rather bend slightly inward. This phenomenon is called refraction. When light rays pass through the lens, they refract and converge to a single point to produce an image. Because the image passes through the lens to the opposite side, it is projected upside down. This process alone, however, is not enough to produce a sharp image. This is because, strictly speaking, a spherical convex lens alone cannot cause light to converge to a single point. The focal point where light rays passing through the center of the lens converge differs slightly from the focal point where light rays passing through the edge of the lens converge. This is called spherical aberration. In addition, color fringing may occur. This is called chromatic aberration. When light passes through a convex lens, the focal point for red light, which has a long wavelength, is farther away from the lens than the focal point for blue light, which has a short wavelength. This causes colors to shift. As a result, colors appear to bleed. Making light converge neatly to a single point requires technology. Since the direction in which spherical aberration occurs in a convex lens is opposite to a concave lens, through a combination of two or more lenses, light rays can be made to converge to a single point. This is called aberration correction. Chromatic aberration can also be corrected by combining two lenses. To achieve the most beautiful images possible, actual camera lenses incorporate multiple individual lenses that correct focus and color bleeding. Lenses for single-lens reflex cameras are made up of a large number of lenses. Each lens is responsible for such roles as adjusting colors, distortion, and focus, as well as changing the focal distance. Canon takes pride in its diverse lens lineup. Each model features technology designed to capture beautiful images.
Dear students, thank you for watching and see you in other science episodes.